So this lesson is on a technique or a method of integration using something called U-Substitution. So first what we're going to do is we're going to look at how we've been integrating polynomial type functions. So that's what we've been working with so far. And remember that you're doing the reverse power rule. So if I want you to integrate x squared dx, you're going to add 1 to the exponent, divide by the new exponent. So if we integrate this, it will be x to the 3 over 3, or 1/3 x to the 3. What's going to happen is the functions that we're going to be integrating are going to be much more complex, and they're not going to be written in these polynomial type functions where we could just integrate each term. So look at this question, which we're going to be integrating. So unless you expanded this out 4 times, and then distribute it in the 2x to turn it into a polynomial type function, there has to be a different way to integrate this, and it's something called U-substitution. So what the first step is in U-substitution is to identify the inside function, and the inside function you are always going to call U. So within this integral that I'm going to be integrating, or this function that I'll be integrating, this is the inside function. So I'm going to say let u equal x squared minus 5. So you find the inside function, and you're going to call that u. The second step is to take the derivative of the inside function. So what we have is u, so we're going to take the derivative of u with respect to x. Okay, so let's go to this inside function. So we're going to differentiate u with respect to x, and the derivative of x squared is 2x. The derivative of minus 5 is 0. Then step 3 is we're going to write everything in terms of u. So here's what we're going to do with step 3. I'm going to take this integral, and I'm going to rewrite this. So right now, I have 2x. I've identified this inside function as u to the power of 4 dx. I need to only have u's in here, one variable to integrate. So I'm going to get rid of this dx first. And what I'm going to substitute in with is I'm going to go over here, and I have a dx. I want to isolate this dx by itself. So you can cross multiply, get dx by itself, or what dx is going to be equal to, right? So think about cross multiplying. You would multiply both sides by dx, and then you divide both sides by 2x, right? So dx, when it's in the denominator, basically these two will just swap. Sort of just showing you cross multiplying in one step. So dx is going to be equal to du over 2x. So now I'm going to rewrite this. I'm going to take out dx, and I'm going to put in du over 2x. So that is equal to, so I have the 2x, I've got the u to the 4, dx is now going to come out, and I will have du over 2x. I have u's in there now, but I still have x's, but it cancels. So 2x over 2x will cancel. So now what I'm integrating is u to the power of 4 du. I'm going to integrate with respect to u, and use your reverse power rule to integrate this. So that would be u to the 5 over 5 plus your constant of integration. And that's what the integral is. And now I could just resubstitute back in u, and I would be done. And we're going to check by taking the derivative. So, right, this is equal to. So u, remember we identified as x squared minus 5 to the power of 5. I'm going to put this 1/5 in front plus the constant of integration. So box this in. That's our answer. But I'll show you how we could take the derivative of this, and we'll land right back here. So just watch up here. You don't have to do it in your notes. If I was taking the derivative, I'd be using the chain rule. Okay, I'd have 1/5 times 5, which would be 5 over 5. Then I would have x squared minus 5. If I'm taking the derivative, I'm subtracting 1 to the power of 4. Then I take the derivative of the inside function, which is 2x. The derivative of the constant of integration is 0. This matches back to what we started with. Okay, so we're just going to do several of these so that you are comfortable integrating. More complex, these are composite functions. Okay, so find the inside function and identify that as u. So step one is always identify the inside function as u. So let u equal x cubed minus 2. Then you're going to take the derivative of u. So we're taking the derivative of u with respect to x. So that would be 3x squared. Now I'm just going to write this, and I'm going to take out my inside function. I'm going to input a u. So it would be the integral of 3x squared u to the negative 3 dx. Everything can only be in terms of u. So at this stage, I always like getting rid of dx, though later on you'll see we'll make this quicker and we'll get rid of it right away. But right now, rewrite this in terms of dx. So dx is equal to, remember these two, so it'll be du over 3x squared. So now I'm going to write this as the integral of 3x squared u to the negative 3 dx is replaced with du over 3x squared. It nicely cancels again. We're going to do some later on where the numbers won't cancel, but the x's have to cancel because I can't integrate with two different variables. Yeah, yes, but you'll see some will look different, and then, but yes, that's what you're ideally looking for. That's the connection, okay? So now we write this as, we're going to integrate u to the negative 3 du. Everything's in terms of u now. So you're going to add 1 to the exponent and divide by the new exponent. So that's going to give you u to the negative 2 divided by negative 2. And I'm going to just put a 1 here, plus your constant of integration. That would be 1 over 2. U is x cubed minus 2. Plus your constant of integration. Was it? No, x to the 3 minus 2. Oh yeah, so, and this should be negative. Negative 1/2 x to the 3 minus 2 to the negative 2 plus c. And then let's rewrite this, reciprocating to get a positive exponent. Okay, you do this one, and then I'll make it so that the x's will cancel, but the numbers won't. So take a minute to do this. Okay, so when you integrate, your answer is 1/5 x squared plus 5 plus 7 power of 5 plus your constant of integration. Before we identify u, my inside function will be this x cubed minus 4. Let's rewrite this to get rid of the radical. Okay, so this is equivalent to the integral of Let's follow the same steps. Identify your inside function. Take the derivative of u. And here's where I'm going to do two steps in one. I know I always have to isolate dx because I have to get rid of this. So I'm just going to isolate dx, and then I'm going to do my substitutions. So I'm going to say dx is equal to du over 3x squared. So in one step now, I'm going to say the x squared here. This would be u to the 1/2. Dx is coming out, and I'm substituting in du over 3x squared. The x's cancel, which is great because everything's in terms of u, but we now have to deal with this 3. So this will cancel. This 3 is really a 1/3. So I'll show you what I'm going to do with it. I'm going to bring the 1/3 here. Then I have the u to the 1/2 and then du. I have written everything in terms of u. Now, instead of integrating from here, I'll show you one other thing I like to do. So we would add 1 to the exponent, divide by the new exponent. But here's what we could also do to make this just look a little easier. This is your constant multiple. You could actually throw that outside of your integral symbol. So I could write this as 1/3. My constant multiple is in front. Then I'm going to integrate u to the 1/2 du. You will see you'd get the exact same answer, or sorry, this should be du, if you kept it within the integral. Okay, so from here, integrate. So that constant multiple is 1/3. Add 1 to your exponent. So we're adding 2 over 2, so we're going to get 3 over 2. Divide by your exponent. So dividing by 3 over 2 is the same thing as multiplying by 2/3. Add your constant of integration. This becomes 2 over 9. I'm going to replace u with x cubed minus 4. And to the power of 3 over 2 plus c. I'll just write this as my answer. You could take it one step further. Take the square root of this, right? So rewrite this as a radical. So the square root of the inside function to the power of 3 would be your answer. Okay. Let's do this one. So identify your inside function as u, take the derivative of u, and then isolate dx. So I'm going to do my third sort of step right here. Now when I rewrite this integral, I'm going to have u to the power of 10. There's an x. And then dx, I'm going to substitute out as well. And I'm going to have this. I really want the x's to cancel. Recognize that that is a 1/6. So I'm just going to write 1/6 u to the 10 du. And then when you're really comfortable with this, you would skip this step even, right? And pull out your constant multiple and have 1/6 for integrating u to the 10 du. And then you have a simple function that you're going to integrate. So 1/6, add 1 to the exponent, divide by the new exponent. Add your constant of integration. 6 times 11 is 66. So we'll have 1/66. I'm going to substitute back in u. And I'd have this. Yes. 11. And then again, when I was keying this, I wanted to make sure that this would have worked. So I took the derivative, right? I brought the 11 and I had 11/66, the inside function to the power of 10. And then when you multiply by the derivative of this, which would be 6x, it'd be 66/66, which would cancel. And you'd get an x and then this to the power of 10. So if you take the derivative, you would get right where you started. Okay, this will be the last one before we do U-substitution for trig. It's harder to see what the inside function for this would be. What would you pick u to be? The numerator or the denominator? Yep, yes. You can, but I don't want you to do that for this one. We could do that after. There's a reason why. What I want you to see. You would get the exact same answer though if you do that. Okay, so we're going to let u equal to x squared plus 3. We'll take the derivative of u with respect to x, and we'll get 2x. We'll isolate dx, and we will get du over 2x. I'm going to rewrite this as 2x over, that's my u, dx, I'm going to take out, and I'm going to put this in. Those 2x over 2x will cancel nicely. And here's what we're integrating. Okay, so what Hunter had said is, could we bring that up? So Hunter, you would get to this spot here, and there's going to be an issue. If we bring the u up, we're going to have u to the -1. Do you remember this issue that we ran into? When we integrate this, you add 1 to the exponent, which would give you u to the 0 over 0. So this is the one time we can't integrate the way we're used to, using the reverse power rule. So what is the antiderivative of 1 over u? From logs. So just write this off to the side. Remember that the natural log of u. If I say differentiate the natural log of u, the derivative of the natural log of u was u prime over u. So u prime would be 1 over u. That means that if I integrate this, the integral of 1 over u would be the natural log of u. But what did we have to do with the u when we integrate? So this is going to be equal to, so the integral of 1 over u is the natural log of u. But remember, when we are integrating, it has to be the absolute value of u. And then I'm going to put plus my constant of integration. This is equal to the natural log of u is x squared plus 3, and then plus c. This is the answer, which would be acceptable. But one thing I want you to think of, remember the argument for a natural log always has to be a positive number. So in this scenario, it doesn't matter what x is, this argument will always be positive, which means that I don't necessarily, I don't need the absolute value. So if anybody said that the answer was the natural log of this, they would be correct, right? But when we just have the natural log of u, or sorry, of x, remember that we can't have a negative argument, so that's why like we're putting that always in an absolute value. So either of those would be acceptable. Okay, let's look at integration with trig. And we'll just do a few of them, and then we'll finish off next lesson. So these are all of your integrals, but we're going to do one off to the side here. Okay, so what I want you to put up top is if I asked you, I'll give you the easiest derivative from the trig functions. If I say I want the derivative of sine of x, what was the derivative of sine of x? Cos of x, right? The derivative of sine of x is cosine of x. So therefore, if I asked you to integrate cos of x, we will get sine of x. So right here, I don't have it filled in. The integral of cos of x dx will be sine of x plus the constant of integration. Here would be your check. Okay, so let's do just one check off to the side. Let's take our answer and take the derivative of it. So your quick check will be sine of x plus c. Take the derivative of that. The derivative of sine of x is cos of x. And the derivative of the constant of integration is 0. So it matches. Here is what we're going to be differentiating. And I just want you to jot off to the side the mistake that students will make if we don't do U-substitution. So off to the side, I want you to write the derivative, or sorry, the integral of cos of 3x dx. You'll remember that the integral of cos of x is sine of x, right? So students are going to say, okay, they're integrating cos of x, so it's going to be sine of 3x plus c. That's what students will want to do. But now what I want you to do is I want you to take the derivative of this. Because if you take the derivative of this, you have to land back here to know you're correct, right? So rewrite this and take the derivative of it and see if you get back here. So if I take the derivative of sine of 3x plus c, I know that the derivative of sine is cosine inside function stays the same, and then you multiply by the derivative of the inside function, which is a 3. So this cannot be the integral of this. So we're going to use U-substitution. What's my inside function? Yeah, this is the inside function, right? We take the derivative of the outer function, and then we take the derivative of the inner function. So my inside function is 3x. So let u equal to 3x. Take the derivative of u with respect to x, and you'll get 3. Let's isolate dx, and we will get du over 3. Let's rewrite our integral as the cos of u dx. I'm going to substitute with du over 3. This, remember, is 1/3, right? So I could write it in front of cos, but now hopefully you could see I could just write it in front of my integral symbol. So that 1/3, I'm going to write out here. Then I'm going to integrate cos of u du. Now I am in terms of u. So let's integrate this. We have 1/3. You know that the integral of cos of u is sine of u. Okay, so we know that. Plus my constant of integration. This will be 1/3 sine u is 3x plus the constant of integration. This will be the antiderivative. And watch the check. So the check would be, I'll just do it for you. If you take the derivative of this, I'm just going to bring down my constant multiple. The derivative of sine of x, or sine of u, is cosine. Then you multiply by the derivative of the inner function, which would be a 3. These will cancel, and we get back to where we started. Okay? If I ask for the integral of secant squared, sine and cosines you have to have memorized. But if I'm giving you the integral of any of the other trig or reciprocal trig functions, you'll be provided with this. So tan of x, the derivative of tan of x is secant squared of x. So the integral of secant squared is tan of x. But let's do our u substitution. So secant squared of u, and I'm going to replace dx with du over 8. This is 1/8, so I'm going to pull my constant multiple out. I'm integrating secant squared of u. The derivative of tan of u is secant squared of u. So the integral of secant squared of u, you will be given this, is tan of u plus a constant of integration. So I'll have 1/8 tan of u plus my constant of integration, and that would be 1/8 8x plus c. We'll do one more trig, this one. So match this up, like look at the previous page that you have with a cosecant and a cotan, and what would the integral of that be? So cosecant and cotan, the integral of this is negative cosecant, okay? So pick what u would be. U would be your inside function. Take your derivative. Isolate for dx. Rewrite in terms of u. Don't forget that x. Now I'm in terms of u, so I'm going to integrate. The integral of cosecant of u cotan of u is negative cosecant of u. So I'll put my negative here. Okay. And that would be your answer.